Okay, what the heck is the difference between a TPU and a GPU? I read up about it. GPUs and TPUs both power artificial intelligence, but they work in completely different ways. Start with the GPU. Originally designed for video games and graphics. Graphics require calculating millions of pixels at the same time. GPUs became experts at parallel processing. For AI, a GPU splits work across thousands of tiny cores, all running simultaneously. But here's the problem. GPU cores are blazing fast. The memory sits on a separate chip. Every time the GPU needs data, it fetches from external memory. Cores sit idle waiting. Think of a chef running back and forth to a distant pantry, more walking than cooking. This is called the memory wall. It slows everything down. The upside? GPUs are incredibly flexible. Same chip runs AI models, video games, and video editing. But flexibility means compromise. Not perfectly optimized for any single task. Now consider the TPU, an ASIC built specifically for AI math. TPUs use something called a systolic array. Data flows through a grid of processors, like blood pumping through a heart. Each processor calculates and immediately passes results forward. No round trips to main memory. The memory wall disappears. TPUs dominate when processing massive batches of data. Training large AI models becomes extremely efficient. But there's a catch. When one person asks a chatbot a single question, the entire array still activates. The pipeline must fill before results flow out. This creates latency. GPUs handle single queries better because cores work independently. So what's the verdict? GPUs offer flexibility and responsiveness. TPUs deliver specialized efficiency. Training a massive language model. TPU wins on speed and cost. Running a real-time chatbot for individual users, GPU responds faster. Gaming or video editing, only GPUs work. TPUs cannot handle those tasks. Different tools for different jobs. Understanding the architecture explains why.